All right, so hopefully you started this problem. If you haven't, you need to pause it and wait until till you get a chance to do it. We're going to do it now. As we do this problem, there's a new idea. And the new idea has to do with our base. Our base of our shape, of our volume, is no longer what a nice, easy, got an axis on it sort of thing. Instead, the dumb thing we have a line like this, and we have a parabola that does this. And so our known base area is going to be this piece right here. Okay? And since we're talking about perpendicular to the x-axis, so the x-axis is this way, so perpendicular to be this way, so the bottoms of my graph are still going to be up and down, but I got a problem in that they're not just y anymore. They're the y of the line minus y of the curve. Okay? So more on that in just a moment. It says here the volume is composed of rectangular cross sections, rectangles now, where the base is 1/3 of the height. So if I go ahead and draw my rectangle over here, which I should do, there's my rectangle. The base is 1/3 of the height, so the height is going to be taller. And so whatever this green value is, this is going to be 3 green. Okay? The problem is the value of green is changing as I walk along the x direction, right? We're going to walk through the x direction because my shapes are perpendicular to the x direction. So why not walk in the x direction? And so I'm walking the x direction, I need an area formula in terms of x. So I look at this problem and go, oh, what a nightmare. But then I realized something simple. I said, look, it's going to be whatever the value for the line is minus whatever my value for my curve is, right? So essentially it's going to be y2 minus y1 is the bottom of this graph, right? So and that's going to vary depending on what your x values are, right? But the good news is I need it in terms of x anyway. So I know that y2, the taller of the two graphs, is going to be x. The shorter of them is going to be x squared. So the bottom is always going to be, for any value of x you pick, it's going to be from x to x minus x squared. So let's say I put a half in here. Let's say I'm going to the halfway point. The distance between them would be 1/2 minus 1/2 squared, which would be 1/4. Okay? And so therefore, this works for all values. As long as I get a value of x, I can tell you what the distance between the top part and the bottom part is by simply subtracting them. Okay? All right, and so that means that this side over here is going to be 3x minus x squared. And so I end up by multiplying. I got some formula to do because it's a rectangle. The area of a rectangle is base times height, so it's going to be x minus x squared times the height, which is going to be 3 times x minus x squared. I'm going to go and FOIL it first because that's usually the better way to go. I got x squared minus 2 x to the third plus x to the fourth. I still got a 3 sitting out in front. Whoops, sorry, chopped my 4 there. Is the area, and so now my area is going to be equal to 3x to the fourth minus 6x to the third plus 3x squared. That is my value in terms of a. Now, where my starting point? It didn't tell me this time. Well, I look at my picture, I go, look, they all meet it, those two meet at 0, 0. I plug in 0, yep, 0, 0. And then over here, where is this point? And usually be something I can guess at. In this case, it's going to be 1, 1. Okay? Worst case, you could actually solve it, right? You could say y equals x and y equals x squared. So therefore, x squared equals x. That happens where x squared minus x equals 0. I factor, I get x minus 1. And so I get x equals 0 and 1. Okay, so I could solve for that if I really wanted to. In a really nasty situation, you should remember that you have a function on your calculator that your trig teacher explained to you at great length last year to say that where do these things cross? Intersection. So you go to your calculator and you find where they intersect. Okay, different instructions for different calculators. Again, probably not going to get, soon we get around to taking a test on this. I'm probably not going to give you one that requires a calculator to find the points of intersection, but you might want to play around that button because it will save you some time and effort if you like calculators in that way. Okay, so we're integrating from 0 to 1. We've got 3x to the fourth minus 6x to the third plus 3x squared dx. Raise its power by 1, divide by the power I get. Raise its power by 1, divide by the power I get. Raise its power by 1, divide by the power I get from 0 to 1. So this becomes 3/5 minus 3/2 plus 1 minus 0 plus 0. And so I end up with a mess on my hand. So let's figure this out in a second here. This is 1, this is -1/2, so this ends up being 3/5 minus 1/2. So that gives me 6 minus 5 over 10, which is 1/10. So the area between those two curves, if you make rectangles that are 3 times as high as what the base would be equal to, that whole volume be equal to 1/10, whatever the units are, cubed. All right, the back is all yours. As a reminder, do not do solid ellipses. We don't know how to do the area of a solid ellipse, and so the very last problem asks you to do a solid ellipse. So please don't do the last part of the last problem. You should be able to do everything else. As you have questions, please send them to me, and I will try to pen to the message where you got this. Other sorts of videos and things that I can make work for you. All right. Okay, and try to be specific with your questions, because obviously we're doing this by typing and whatever, and it's not nearly as effective as actually having a conversation back and forth. So it'd be easier to address your questions if you make them as clear as possible. So thank you much, and hopefully everybody is doing not just well, but they're getting a little extra exercise inside their house. They're getting all those little chores they've wanted to do in their house. You've got all of your college stuff getting straightened out, and you're having a good time with this, because after all, you've wanted to stay in your house and not go to school for a very long time. Sorry to intrude on that, but you should do some math while you're there. So talk to you later. Bye.